Good afternoon. I'd like to welcome everyone to today's program. I am Kit Poliano, the Dean of the Division of Biological Sciences at UC San Diego. For those of you joining us for the first time, the Division of Biological Sciences is celebrating our 60th anniversary with a deep look into the future of biology public speaker series. I'm very honored to welcome you to the second installment of our fall lineup of Deep Look programs. Before we get started, I'd like to thank the alumni and graduate offices which have partnered with us in this series. Today's program is a special homecoming edition in the Deep Look series, so I'd like to give a special welcome to all of our alumni who are joining us today and hope that they continue to engage with the other campus programs offered as a part of homecoming. We featured a broad range of timely and relevant subjects in this series. But I'm especially excited about today's subject since it touches on every one of our lives. Today, we will be addressing trust in science and specifically issues related to mass and COVID-19 infection, vaccines and disease spread, as well as core underlying issues that are so vital in today's society. Science communication, authenticity, and public trust of science. Given the importance of these topics and their immediate impact on our present and our times and our future, I'm very grateful that we have 4 leading experts in these areas who will discuss these topics and take your questions later in the program. Today, you'll be hearing from 2 scientists, an atmospheric chemist and a biologist, and also from 2 science communication experts, one from the Division of Physical Sciences and the other from the Division of Arts and Humanities, who together lead our research communications program, which works to train our scientists in becoming effective communicators of their science to public audiences. First, you'll be hearing from Professor Kimberly Prather, Distinguished Chair in Atmospheric Chemistry and Distinguished Professor at Scripps Institution of Oceanography and the Department of Chemistry and Biochemistry. Over the course of her career, Professor Prather has authored more than 200 publications in a wide range of prestigious scientific journals, and a primary focus of her research involves understanding how aerosols impact climate and human health. She is the founding director of the NSF Center for Aerosol Impacts on Chemistry of the Environment. Today, she will be discussing aerosols and mass in the spread of COVID-19, a topic upon which she has been featured in hundreds of news outlets over the past few months. Next, you'll hear from Stephen Hedrick, a distinguished professor in the section of molecular biology in the Division of Biological Sciences. In his lab, Steve has studied T-cell mediated immunity, which means by the mechanism by which T-cells recognize infectious agents. He's interested in how T-cells perceive and integrate information in order to combat pathogens, as well as in the co-evolution of the host and the pathogen. He was recently named to be a member of the inaugural class of Distinguished Fellows of the American Association of Immunologists. After Steve, you will hear from Sherry Seathaler, Director of Education Initiatives in the Division of Physical Sciences, who teaches research communication and co-leads our research communications program. She was the Science Questions Answered columnist for the San Diego Union Tribune for more than 7 years, and she has published 2 anthologies of her columns, Curious Folks Ask, 1 and 2, and she's also the author of Lies, Damned Lies, and Science, which provides practical strategies to help people sort through science and health information. Sherry will be talking to us about what research tells us about how to navigate through communication misfires and have productive conversations during these contentious times. And finally, we'll hear a presentation from Kim Rubenstein, professor in the Department of Theater and Dance. Kim is a highly respected and award-winning theater director who is Associate Artistic Director of the Long Wharf Theater and has directed plays throughout the country. She spent 10 years on the acting and directing faculty at Northwestern University and has taught at the University of Chicago, the Brown and Trinity Consortium, Wesleyan University, Yale, and the National Theater Institute at the O'Neill Center, as well as her ongoing teaching with the school at Steppenwolf and her ongoing teaching at UC San Diego in our research communications program. Kim co-leads our research communications program has designed and led communicating science workshops for faculty, graduate students, and others in the biological sciences, physical sciences, Scripps Institution of Oceanography, Jacobs School of Engineering, School of Global Policy, and the Graduate Division. So following Kim's presentation, we'll welcome your questions, and we look forward to a lively discussion with our panelists. And I know that there'll be something here for everyone, and you're going to have a great time. So thank you so much for joining us, and we'll now get started with our speaker presentations.
Okay, today I'm going to talk a little bit about COVID-19 and what we know about how it's being transmitted and how we've ended up in a global pandemic with this particular virus. And so this is a perfect topic for public confusion because there's been a lot of confusion about how this virus is making its way around our world. So early on in the pandemic, and I think most people will probably remember, we were told that transmission mainly occurs through these really large droplets, size, bigger than 5 microns. To some people that won't matter, but, big droplets that we traditionally think about coming from people who cough and sneeze. And the good thing about these droplets, if that's where they are, is that they settle to the ground within 1 to 2 meters. So within 3 to 6 feet, they'll fall to the ground, and then we have to worry about touching them or them landing on us in some place that would lead us to be infected. So we were told by the WHO and CDC, the key thing we needed to do was to disinfect surfaces, and we had to stay at least 1 to 2 meters apart to reduce this transmission. We were also told that masks are not effective, and at the very least, we should save them for healthcare and frontline workers. And one of the main things we were told was that if you have a fever or you're coughing or sneezing, you should stay home. And that was enough, supposedly, to limit our sort of the transmission of this virus. WHO, just to give you an example, this is March 28th. This is a tweet that they put out, which is, basically flat out stated, this virus is not in the air. And so, this was all over, just disinfect surfaces, pay attention to coughs and sneezes. And this is where we started. So as a scientist who communicates to the public, I can understand the confusion. And I've spent the last, 6 months of my life trying to undo this and get it to a better place where we can actually protect ourselves appropriately. And so that's what I will be telling you about today. So this field of respiratory transmission is like over 100 years old. There's medical books written about, textbooks in the medical field, all about droplets. Nothing hardly at all about airborne transmission. In fact, we were told we weren't even supposed to mention the word airborne transmission. And so the focus at the time, going into this was that, people cough and sneeze when they're sick. And these big droplets, they travel like little mini cannonballs and they immediately fall to the surface. So it was all about surfaces. Aerosol scientists who study aerosols, the tiny stuff, come in and say, no. In this particular virus, it's not about the coughers and the sneezers. It's about people just speaking or singing or talking loudly. And when you do that, you produce thousands of aerosols. And so thinking about the behavior of a big droplet versus an aerosol, you can compare little mini cannonballs to aerosols that are like cigarette smoke that fill a room. And I've shown a picture of this. We've all been in a smoky room. Those are aerosols. And that is more in line with how this particular virus is being spread. And so one of the big sort of disconnects between what people thought was happening, what the medical field thought was happening, and what's really happening has to do just with this distinction in terminology of what we define as an aerosol versus a droplet. And so around the time when we kind of came into this story, we basically realized that these aerosols, are being transmitted by people that are largely asymptomatic. And by that, it means they have no symptoms. Most people don't even know they're sick. So 10 to 20% of the people who are walking around, they're not coughing and sneezing, they have no idea they're sick, are leading to 80 to 90% of the infections. That is how this virus has made its way around the world, and we've ended up in this global pandemic. And so we came along as aerosol scientists. We said, you've missed the aerosols. They're invisible, but we've been measuring them actually for decades. Here they are. When you talk, you produce aerosols. They contain the virus. And that is probably most likely what is leading to the spread of this disease. So I stitched it all together. I study aerosols. I run a direct and major NSF center on aerosols. I put it all together and said, okay, if this is how it's getting around, if it's getting around through airborne transmission, then, the key thing is that everybody has to wear masks. And basically the goal there is, it protects you as the wearer, but more importantly, if you don't know you're sick, it blocks what you're sort of spewing out. And so this figure has made its way. It's been translated into, I don't know how many languages. It's used everywhere to sort of show the public, communicate to the public. We're not just telling you to wear masks. We are explaining to you why it is important. And this has had a huge, very positive impact. Going forward, it's approaching now 500 interviews on aerosols and what it means to be in the air. I've talked on CNN, CBS about, how are we getting infected by this particular virus? And, I've even went so far as to brief multiple times Dr. Fauci on it's in the air. It is in the air. It is not on surfaces. And if we don't tell the public the truth of what is really happening, then we can't protect the public appropriately. The bottom line is I say, people were really worried, and you talk about why there's a lack of trust. People were worried about this, sort of message. If you say it's airborne, people are going to say, oh, they're going to get scared. I have never had anybody get scared by my message. I've always emphasized, once we acknowledge it's in the air, this is a very, very fixable problem. And it also tells the public why they should bother to do the things we're telling them to do. There's a huge trust issue behind just telling people the truth in terms of public health. So we kept going. There was about, 10 of us, I guess, in the world that just continued to apply pressure to the CDC, the US version of the WHO, to acknowledge it is in the air. And so finally in July, we wrote a paper, 239 of us signed this paper, this open letter to WHO saying it's time to say it's in the air. New York Times said it's in the air. It is in the air. There is no question that is how this virus is spreading through people around the world. So then we basically decided that it was important, we needed to sort of make the point even stronger. We wrote a letter to Nature, and this just came out not too long ago. Basically with the title, Airborne Transmission of SARS-CoV-2. 300 words, it's in the air. This is what we have to do. We have to shift our focus from surfaces to the air, and this is why. And so this has received a lot of attention by the public, by public health. And again, we just sort of continue this pressure on the public health officials to sort of tell the public like it really is. And within minutes of our letter coming out, the CDC came out with new guidelines that acknowledge that this virus may be adrift in the air. There's a long story behind this. They had something out saying it was airborne. They pulled it back. They put it back. It's just gone back and forth. Finally, CDC said it's likely airborne, and this is why you should care, and gave new guidance. And this came out, as I say, within minutes of our paper. So the key point, why are we pressing? Why have we pushed so hard to make, this airborne transmission aspect important? And it's because once you acknowledge it's in the air, you can fix it. And this gets back to, if you ignore it, it's not going to go away on its own. That's obviously not happening. So there's many things we can do, and there's many things we shouldn't be doing. So if it's aerosols, this figure just shows one of the things people have done is they've stuck up plexiglass barriers everywhere. Classrooms, grocery stores. This shows the simulation, fluid dynamics. You can do it at a high level. It shows that actually plexiglass doesn't block you from aerosols. The aerosols just flow right around. And in fact, they can concentrate on the other side of plexiglass barriers. The better thing to do, instead of focusing on cleaning surfaces, is cleaning the air. And so, through ventilation, better ventilation, through filtration, you can actually, this down here is an inexpensive box filter, just a box fan that you can get. You can strap on a MERV 13, which you can buy at your local hardware store. $40, you can actually filter out aerosols that potentially have this virus. The other thing you can recognize is that outdoors is much safer than indoors. The number of cases that have been outside is like in China, they did 7,000 studies and found out that there's one case outdoors. The rest have all been indoors. Looking back, this is not new. 100 years ago, we had classrooms outside. We opened windows in classrooms to protect people. So it is all about, once you acknowledge where it's really coming from, the fix is very, very obvious. So then thinking about the public and how they can take this information and help themselves is, you got to avoid, or at least limit your time, because it's an integrated exposure. You have to limit the amount of time you spend in places like restaurants and bars, places where people are yelling with no masks and no ventilation. Don't go to those places. That's where most all of the major outbreaks are occurring. Face shields alone don't work. The aerosols, again, just flow right around. You can wear a face shield with a mask, and there's reasons to do that. So finally, I'll just say that, there's no perfect metric of how to protect ourselves, but this is a great analogy that there's sort of the Swiss cheese approach. This virus will seep through every sort of different type of protection intervention, but there's only, sort of after you stack them up, that is how we get to full protection against this airborne virus. And the last thing I'll say is coming back to this comment about public communication. When I gave the CBS interview, a 8-year-old listened and then drew this for her mom. And I would say this is, again, more evidence that there is no fear. There's just clarity in understanding where it comes from. This was an 8-year-old who didn't want to wear a mask. After listening to it, she drew this picture and said, I don't really like masks, but I understand. We don't want to share our spitballs. And so that is the level that I think as a communicator of science, when an 8-year-old can translate what you said, this is, sort of the ultimate positive feedback that I've gotten. And so with that, I will stop.
I would like to speak to you today about vaccines, both as one who has studied and taught immunology for most of my adult life, and as a citizen of the world. My interest in vaccine acceptance was piqued when I found that some of my daughter's friends were reluctant to vaccinate their children. In fact, one of them contracted measles on her honeymoon in Italy, having not previously been vaccinated. At the same time, the Los Angeles Times published an online database showing the percentage of students with measles, mumps, and rubella vaccination at each elementary school in the Los Angeles area. And I found that the school to which my grandchildren belonged or attended had only a 65% prevalence of MMR vaccination. So after several years of thinking and writing about the problem of vaccine coverage, I came to understand it from several points of view. And the first is that we human beings are the most diseased species on Earth. And this comes not from some way of knowing the extent of disease for every species in existence, but rather understanding the epidemiology in recent human history. Our history over the last 2,000 to 3,000 years has included one epidemic after another. Epidemics that often killed 25% or more of the population in any given region of the world and lasted decades or sometimes even centuries. But even this is a great underestimate of the effects of epidemic disease on human history. Since the dawn of history, we have been continually plagued by what Jared Diamond called crowd epidemic diseases. Until the latter part of the 20th century, most families lost children to smallpox, scarlet fever, pertussis. There were birth defects caused by rubella. Occasionally children died from measles. And in other parts of the world, malaria still kills about 400,000 people per year, mostly children. This sort of epidemic disease was continuous for at least 2 millennia. Many more people died of these diseases than all the wars combined. And the question is why? We're exceptionally intelligent as human beings, but why are we as a species exceptional with respect to the loss of life due to infectious disease? And the answer is, in a very short span of time, we human beings completely changed our ecology. We evolved as small dispersed communities of hunter-gatherers consisting of a few hundred individuals. But with time, we domesticated plants and animals, and eventually people became situated and lived in permanent communities of much higher density. At the same time, we sampled all of the infectious agents to be found in cows and sheep and horses and goats and birds, meaning we captured many infectious diseases from these animals, infectious diseases that were not evolved, or if you will, tuned to human beings. So how does this affect infectious diseases in the modern world? So this is a short version of what we call human disease ecology. And the first point is that pathogens found in low density populations are long-lasting and exhibit low or infrequent tolerance. That is, they exhibit low disease. You can imagine that this is because a pathogen that is too virulent would kill its host before it can be transmitted to the next host. And in low density populations, it takes a long time for diseases to be transferred from one person to another. Conversely, in high density populations, pathogens are able to be transmitted rapidly from host to host. And so there's no selection pressure to keep hosts mobile or even alive. And one metaphor for this could be a forest and the possibility of a forest fire. So if we consider an isolated stand of trees in a green meadow, this would pose no danger of a raging fire, just as an isolated band of hunter-gatherers posed no danger for a large-scale epidemic. Whereas for a dense, interconnected forest, one spark can ignite a holocaust, causing widespread damage that lasts a long, long time. Another point is that zoonoses are infectious agents that jump from one species to another. And as their virulence is unpredictable because they haven't co-evolved with their host, zoonoses are very dangerous. And examples being Ebola virus, Lassa fever, hantavirus. They jump into the human population. Oftentimes they only infect a few hundred people or a few dozen people, and then they fade out of the population. And this was the case for Ebola virus until about 2014, where it evolved to be more infectious. And so now it can cause epidemics. And the concept is that we human beings are not only culturally connected or genetically connected, human beings worldwide are biologically connected in the present through our exchange of infectious agents and our common susceptibility to disease. We are more than simply individuals coexisting on the same planet. We are all hosts within a disease network of microbes and viruses. For example, as long as one person on Earth harbored variola virus, which is the cause of smallpox, billions of people, the entire population of the world, was at risk. Infectious diseases show the real-world consequences of individual actions on the community of humankind. So let's visualize this schematically. This is what the world looks like presently in the COVID-19 pandemic. Most people have not encountered the virus. Of the almost 8 billion people on Earth, most have not contracted the disease. There are people, the ones in red, that are infectious. And then there are a few people who have had the disease, and we hope they are immune. We don't know that yet, but we're hoping that this is the case. Now, one way that this could end would be after a decades-long pandemic, in which you might argue you could encounter herd immunity. That is, most people have had the disease and are now immune, and the disease starts to die out. Of course, it doesn't die out completely because there's always an influx of susceptible new hosts in the form of newborn children. And so this is how diseases typically go from being epidemic diseases to being childhood diseases, where most everyone gets the disease as a child and either dies or becomes immune. Now, just yesterday, the Director General of the World Health Organization was quoted as saying, "Never in the history of public health has herd immunity been used as a strategy for responding to an outbreak." So rather than waiting for a decades-long epidemic for this to decrease. We need a vaccine, and we need an effective vaccine. So let me just go over very quickly what the types of vaccines there are and what types are being developed for COVID-19. The three types of vaccines that are currently licensed in the United States are whole inactivated virus, live attenuated virus, and subunit vaccines. The whole inactivated virus is similar to that was developed by Salk for the polio virus. And it is a virus that is grown. It's the wild type virus, but it's inactivated chemically, usually with formalin. On the other hand, a live attenuated virus is an actual live growing virus, but it's been selected so that it doesn't cause disease. And examples of that are the MMR virus, the Sabin vaccine, the vaccine for shingles, the vaccines like that. And the third type is the subunit vaccine, in which you make a protein that comes from the virus, usually by recombinant DNA techniques, and you add to that something called an adjuvant. Now, what's been occurring over the last few years, and now it's been accelerated at warp speed, we're told, are the development of new types of vaccines. And one of them is to use recombinant viral vectors. These are vaccines in which a innocuous virus, perhaps adenovirus, has been genetically modified to encode one little part of the SARS-CoV-2 virus. And so an individual would be infected with the adenovirus and make an immune response that would include an immune response to this a portion of the COVID-19 or the SARS-CoV-2 virus. Another is to use DNA or RNA directly that's encapsulated, usually in a lipid nanoparticle. This type of a vaccine then turns your own cells into a factory for producing viral products, and then your immune system responds. What all of these vaccines have in common is the ability to provoke an inflammatory response, which is redness, swelling, heat, a little bit of pain. And this is actually needed to initiate a production of long-lasting immunity. None of these agents are intrinsically toxic, but the temporary discomfort that they produce is the result of the onset of an immune response. When your arm is sore after an influenza vaccination, that's because your immune response is actually working. And finally, for this, we can again rely on Tony Fauci, who said that finding an effective vaccine to prevent the infection with SARS-CoV-2 is an urgent public health priority. So once we make a vaccine, how do we know it is safe? Well, there are a lot of means in place to ensure for this. And the first is that the Food and Drug Administration analyzes the clinical data to ensure that there is safety. And in clinical trials for vaccines typically include tens of thousands of patients, half of whom get a placebo and half of whom get the vaccine. And both the safety and efficacy of the vaccine under study is then analyzed. It's only when that is determined to be safe is it then released for general public vaccination. Most of the most of the potential for clinical adverse effects are found at this stage before it ever gets to general public vaccination. Next, the CDC, the Center for Disease Control and Prevention, and the FDA maintain a nationwide monitoring system called the Vaccine Adverse Event Reporting System, which allows anyone to report an adverse reaction, either online, by fax, or by mail. Probably the fax is a little outdated at this point, but by online or by mail. There's also a program that's carried on between the CDC and US healthcare organizations that track the data from millions of people who receive vaccines and then are monitored for their health. And finally, there's the National Vaccine Injury Compensation Program, which receives reports of adverse vaccine reactions studies each claim and then decides whether or not there's a possibility that an adverse reaction occurred based on vaccination. So for example, from 2006 to 2018, over 3.7 billion doses of covered vaccines were distributed in the United States. There were 7,400 petitions for adverse reactions, and 5,000 were compensated. So about 1 in a million vaccine dose results in a compensated adverse reaction. For measles, mumps, and rubella, there were about 108 million doses administered, and from those 108 million doses, 259 adverse reactions were filed and 128 were compensated. Again, about 1 in a million doses. It results in an actual adverse reaction. So let me close by saying that our modern, interconnected, densely populated world is only possible because of large-scale vaccine programs. The difficulty is that as we approach herd immunity in a region, everyone is protected, and thus there's a tendency to feel that vaccination is unnecessary. But I want to say that we remain protected only if the vast majority of the population realizes the importance of community participation in our common immunity to disease. So thank you very much for your attention.
So I'm going to be talking about what research says about preventing communication backfires. First, though, don't think of an elephant. So you might be trying really hard, but probably a white elephant or a pink elephant or an elephant you saw at the zoo has popped into your mind. This is actually the title of a book by George Lakoff, and I start my talk with this example for 2 reasons. The first is that a common way of debunking myths is to repeat the myth and then negate it and go on with the factual information. The problem with this, as you can see from this example, is that simply negating a myth or negating information still emphasizes that information in your mind. It still emphasizes those connections. And so in the process of negating the myth, you're actually giving it credence. The second reason I begin my talk with this is, well, we're very close to a presidential election, and so there's an elephant in the room. Specifically, when we're talking about trust in science and trust in scientists and talking about different scientific issues, to what extent does group affiliation, like political party, influence how people think about different issues? So I have here 3 different issues: human influence on climate, safety of genetically modified food, and childhood vaccine safety. And I'm just asking the question, does political party influence how people reason about these issues? And you probably have some predictions, so I'm going to do the big reveal now. So political party does influence how people make sense of human influence on climate, but it does not influence how people think about the safety of genetically modified foods or childhood vaccine safety. This is from research by the Pew Research Center, and they found that in general, the public's political views don't influence how they think about scientific issues, with the exception of climate and energy. Lately, we've seen some politicization over issues related to the pandemic. So I am going to tell you, and the next slide is going to apply to not just human influence on climate and energy issues, but also to these issues surrounding protecting ourselves from the pandemic and how people are thinking about those. So we want to mitigate cultural clashes. How do we do that? So to the extent that an issue becomes politically polarized, it can create a vicious cycle in that each polarizing cue reminds people that they're a member of a particular political party who's supposed to think about something in a particular way, and that increases the polarization. So to break that cycle, the best thing you can do is try to remove some of those polarizing cues, and that could be imagery or language, for example. This is from Republican strategist Frank Luntz, who changed the way Republicans talked about a number of different issues. An example is drilling for oil became exploring for energy. I'm not suggesting to use these particular words, but this just serves as a reminder that certain words become associated with certain political parties and therefore can be polarizing in that way. Another thing that you can do to mitigate cultural clashes is to work with an ally in the group or to connect via shared identity. So we're not just one identity. We aren't just members of a political party or members of a religious organization. We're parents, we're pet owners, we're people who have certain hobbies, who do certain things and are parts of groups in our community. Any of those can be a way of connecting to another person, a way of looking at their shared identity and relating to that person through that shared identity. Thirdly is a lot of times we get so caught up on the problem, but we really can focus on sometimes the solution. A lot of times we can agree on the solution, even if we don't agree on every single aspect of the problem. Kimberly Prather just talked about the idea of the fix factor versus the fear factor, knowing that there's aerosols and that's part of how COVID is being transmitted doesn't necessarily have to be so scary if we focus on the solution and that there are really practical solutions to decrease transmission. In addition to that, if you think about the idea of having more ventilation in buildings, opening windows, filtration systems, I think we probably could have agreed that those were good ideas before COVID even came along. So sometimes the solution is actually quite palatable and we don't need to get so caught up in the problem. So these are 3 strategies for mitigating cultural clashes. But I don't want to give you the impression that the only reason for trust or difficulty believing science is only related to political affiliation. Some of it has to do with how we communicate about these different issues. As scientists and as communicators, we also have a job to do in making sure that the information we're giving is comprehensible and that audiences can use it to make decisions. An example of that was this incredible certitude around the US Surgeon General's statement on masks. The initial statement was very definitive and it had to be retracted less than a month later. And this has gotten a lot of coverage in the media. So, science certainly changes and that's acceptable. But when we think that there might be uncertainty ahead, which is often, we should be really honest and transparent about that. And that doesn't just mean throwing up our, hands in the air and saying, oh, well, we're not certain about this, because that's very frustrating. But instead, clarifying the uncertainty and really trying to give people the information they need to make decisions. And that includes thinking about saying, what is the source of the uncertainty? How big is the uncertainty? And is it resolvable? Sometimes we're in the midst of a study that's going to come out in a couple of months, and we can say that it might be resolvable shortly. And sometimes we can't actually do the experiment that would make it resolvable. And so that's useful information too, both for individuals trying to make a decision and also for policymakers trying to make decisions and trying to talk to their constituencies. This is just a reminder that trust is built gradually over time, sort of brick by brick, but that trust is destroyed often very dramatically, and not just in a building failure or a dam failure or something like that, but in those moments like that example I gave of the Surgeon General's initial statement on masks that actually broke down trust a lot. So in being communicators, the asymmetry principle of trust becomes really important, that it's really hard and takes time to build that trust, but it can be destroyed really easily. So part of thinking about this is also looking at how we're going to tackle wicked problems. And so wicked problems is this name that's been used to talk about these big societal problems like climate change, like even thinking about what to do about the pandemic, because there's so many different facets of that, not just a couple of facets. And of course, scientific findings need to be brought to bear on the wicked problems, but it's so much more than that, right? Because there's all these different aspects and affects our lives in so many different ways. And so part of that is thinking about what different values are brought to bear and thinking about these problems. And it's not just values in the sense of moral or religious values, but rather all the things that we value as humans and how we think about them. And then trading off as we're, trying to work toward a solution, having discussions, these crucial conversations about those trade-offs. Now, you might think, well, you could get involved in these philosophical discussions that could go on for a really long time if you're going to do this and have these conversations. But we have to remember that we're trying to work toward a solution. It's a design problem. And when you think about it as a problem of design, it's no longer just a philosophical discussion, right? It's very goal-oriented toward finding a solution. My colleague, Kim Rubenstein, is going to talk next about having these conversations and active listening. But before that, I just want to sum up and say what I said. I started with this myth about debunking myths. I gave 3 strategies for negotiating group affiliations, helping to reduce by removing those polarizing cues, working through a shared identity or working with an ally, focusing on the solution, not the problem. I also gave some do's and don'ts of handling uncertainty, highlighted the implications of the asymmetry principle, and left you with this thought of working together on this collaborative design problem, because solutions really are this matter of collaborative design. Thank you.
I have been a theater director and a theater teacher of acting and directing for over 45 years. My burning question has always been, what makes human beings behave the way they do? And the complications of the attempt to communicate. As a planet and society in crisis, we need clear, honest communication. Effective and affective communication is a nourishing relationship between you, your research, and your audience. Dynamic precision and spontaneity are required. Communicating is perhaps the most challenging of all human skills. It is a science and an art form, requiring precise language of your research expertise, along with artful use of example, analogy, metaphor, and story to deepen understanding and meaning in the minds, hearts, and nervous systems of your listeners. Communication is nourishment for your listener and helps them thrive in this chaotic world. Here is a slide of the beginnings of life, floating in the womb of nourishment and connected to the mother through the umbilical cord. If communication is nourishment, then when we communicate to listeners, I think it is important to think about the way we are connected, almost like an umbilical cord, to our audience. We are here when we communicate to reach out with nourishment and sustenance to our audiences. Communicating research from a place of expertise, authentic listening and answering, and dare I say empathy, will often make a lasting impression on the listener and perhaps move the world forward. I hear often from UC San Diego this beautiful quote that one of the missions of the university is the future of innovation with an emphasis on empathy. What does that really mean? What does it mean to communicate with empathy? Communicating is a dynamic relationship between you, your research, and your audience. It begins with you. It begins with you as the mother lode. And from you, you spill your authenticity. It is important to be direct, especially when you're inside this box like I am right now. How do we communicate inside this box when we are looking at other boxes and perhaps many other things on our screen? How do we make that umbilical cord happen in the womb of this new kind of communication? It is so important because we are not able to connect person to person. So we need to really reach through the screen to make a lasting impression on the listener. Show us you as you guide us into the world of your research and why it matters to you, to us, and to the world. Tell us what you know and show us how you feel. Help us to know the burning question that drives your research and perhaps the personal story of the spark or origin of how you began your work, and with a specific focus on solutions, as we have heard today. So there is you, There is your research, and then there is the listener, the other. We must make a connection to their minds, to their hearts, and to their nervous systems by illuminating information which can relieve and sustain us. Active and deep listening, what that means is you're listening maybe to the collective fear, to the collective need, not only in the moment, but in the way the world is right now. It is important to acknowledge the fear and pain of your listeners, to find and express common ground between you and them. All human beings have shared needs like safety, sustenance, love and belonging, self-actualization. Protect us. Help us to know the truth of the problem and a path to fix it. This is your research. The most clicked on word on the internet is the word you. And the reason for that is because with all of the information that is being thrown at us all of the time, when we hear the word you, it's like, wait, is this about me? That's the umbilical cord connection. So perhaps instead of saying the public, maybe we say you. Maybe we say me and us. Maybe we personalize our communication just that way. The other thing I really want to talk about is the fact that your audience, your listeners, have different ways of receiving information. I think of this as diversity of thought and reception. As communicators, we need to reach out to different kinds of imaginations, to different kinds of brains in order to leave indelible, lasting images. People receive and are imprinted by information differently. So an example is in Shakespeare had two different kinds of audiences. One were the royalty, the upper class, who wanted to hear heightened language because that was their entertainment. And then there were the groundlings, the poor people, who wanted to hear things direct. So there was heightened language and there was direct language. So an example is Juliet speaking to Romeo on the balcony. She's very practical. So because Romeo suddenly leaps onto the balcony, poetry comes out of her mouth, perhaps for the first time. And she says, "My bounty is as boundless as the sea. The more I give, the more I have, for both are infinite." And then 2 lines later, she says, "Do you love me?" So you see, we have heightened and we have direct. We have the idea that the more we give, the more we receive. That is active listening. That is deep communication. It is very difficult. It is very difficult, particularly when you are speaking to people who are opposing you. How do you find something in common? This diversity of thought means that some people receive information through images, through metaphor or analogy, through heightened connection. So when I was a little girl, I used to go to the roof of my house when there was a full moon. And I would stare longingly into what I thought was a portal into another world. So what I thought the moon was it was cut out of the sky. And there was a whole white world full of the answers to the mysteries of the universe that I could, if I could somehow get in there, into that portal of light. That's what my imagination was doing when I thought about the moon. Then a couple of years went by and I watched on my black and white TV set astronauts landing on the moon. perhaps one of the greatest scientific moments in history. I, however, was devastated because the moon is a rock. I was very disoriented for a while. Then my father was smart enough to bring me to the library and give me all kinds of books on the moon. And I studied it. I researched it. I researched as many facts as I could about the moon. And if you were to ask me today, what is the moon? I would say it's both. It is both the facts of the moon and it is the poetry of the moon. Because the poetry is connected to our deepest longings, to the future of innovation, to the fertile void spaces that contain leaps of innovation. So as an artist, I received the moon in one way, and perhaps a scientist receives it in another. My hope for the future is that we merge the art and science of communication and of dreaming of ways that we can change the world. So here's a picture of an astronaut. He's got an umbilical cord connected to the mother lode. The definition of mother lode is a treasure of great value and abundance. That is you. You as researchers. You are the mother lode. Have the courage. You know, in Latin, the word core means both courage and heart. So what I hope for the future of communication in a broken and ruptured world, perhaps getting ready to become a new world, what I hope for is that you communicate through the abundance of your expertise and from the abundance of your heart. Thank you.
It's wonderful. So I'd like to thank all the speakers for their fabulous presentations. The first question is from Mary Berube. Help me to understand why the CDC now defines a close contact as someone who was within 6 feet of an infected individual for a total of 15 minutes over a 24-hour period. Is that cumulative accrual of aerosols? And I'll ask Professor Prather to answer that first.
This is more confusion, unfortunately, but I think we're getting closer in a weird way to the answer. So yes, in short, it is exposure. Basically, your risk increases, the longer you're exposed, right? The more viruses you inhale, and it is a cumulative effect. And so this particular recommendation is based on one study where someone interacted with people off and on through their work shift that were infected, and they figured out that they think that it added up over time to where the person became infected. There was no one 15-minute period that could explain why this person became infected. So I would say, in answer to, stay tuned. I am actually working with CDC now, and we are actively trying to improve the language to protect people. And so we're getting there, but it's, answer to your question, it is a cumulative effect. But the wording is still not perfect, if that's what you're wondering too.
Okay, thank you. For the next question, there was a question about whether you would still suggest visiting and staying with extended family at their house. Is that still risky, even if all the parties tested negative? And I think we'll start with Professor Prather, and then we'll turn to Professor Hedrick.
It's risky. And in fact, it's the main way. Now there's a new way. This virus is sort of where the outbreaks are occurring, are family gatherings, unfortunately. There's many, many cases that have happened in the last month or two, because the problem is you can test negative today and be sick, but not know it. Your symptoms won't show up till later. So you would really, if you wanted to be super safe, and I know people that are doing this, they are quarantining themselves for 2 weeks before Thanksgiving, if they're going to be with family. So everybody's quarantining and locking down for the 2-week window before they go mix. That's the only way that I would be comfortable. And even then, you still should wear masks, socially distance, wash your hands, because right now the spread, as you know, is going up. We're heading into a very dangerous zone. It's not looking good. And so the risk is actually very, very high right now. And everybody's got, we call it pandemic fatigue. And we're all tired and we're letting our guards down, and it is showing up in the numbers. So be safe. It's not going to be a fun Thanksgiving and Christmas and holiday period, I'm afraid.
Professor Hedrick, would you like to add anything about the testing and as you'd answered in the chat?
Not much, except for, in addition to quarantining yourself or isolating yourself for 2 weeks ahead of time, you should also get tested.
Right.
But
right.
But the testing, which test you get makes a difference. There are some very rapid tests that have a higher rate of false negatives, and then the nasal swab with PCR is probably more accurate. And so I would recommend everybody gets a test and isolates.
That's great. Thank you very much. Okay, there was another question for Professor Prather. Wouldn't plexiglass stop the larger droplets as water sticks to it?
Right. But remember that the droplets are produced in coughs and sneezes, which is kind of your traditional respiratory illness. This virus is coming out in aerosols, which don't stick. They flow right around the plexiglass barrier. They follow the flow lines. They flow around the edges of a mask. Aerosols float. Just think of smoke, and it would just bend right over the top. So plexiglass barriers are designed to block the ballistic, the cannonballs. And yes, they do block them. But for every one drop, there's 1,000 to 10,000 aerosols that will just bend right around and you'll inhale it. So they're not so great.
Okay, thank you. And then there was another related question about what would the risk be when it comes to going to casinos, or I assume we could say, other kinds of crowded spaces. How do you measure risk, and does room size make a difference in this?
Yeah, so there's there's actually a lot of information on this that, we're working with the public to kind of make them available. What are the highest risk situations? I'd put casinos in there. The highest risk situations are indoors, number one. And basically, smaller spaces. If you're in a much bigger space, you think dilution, the size of the bucket for pollution, or, basically a swimming pool versus the ocean. That's why outdoors is so wonderful, because it dilutes. So indoors, you want to make sure there's good ventilation, which sort of when you're visiting someplace, it's really hard to kind of assess that. So I avoid them. Where people are talking, where people are yelling, where people are drinking, where people are eating, those are all very, very, very like the highest risk places, because they'll take off their masks. So, your number one protector is that mask. And as long as everybody's wearing masks, that reduces it. But once you step inside with people that you don't know, the risk is very, very high. So I won't be going to a casino anytime soon.
I think of it like directly proportional to time and inversely proportional to space.
Mm-hmm, mm-hmm.
So try to keep yourself outdoors in space. And we've stopped going to even outdoor restaurants.
I don't go to outdoor restaurants. I've not been to one yet.
Wonderful. Would either of you travel on an airplane?
I wouldn't. I know people that study the air like I do. We're just starting to, and they're masked up. You can do it in a way where you are pretty protected. Airplanes are supposed, they do a huge number of air exchanges. It's not so much when you're sitting, but again, it gets to the point of the longer the flight, if people are taking off their masks to eat and things like that, that's when it becomes if everybody kept their masks on, and with the number of air exchanges, in theory, it should be safe. There was a report that just came out about how they're the safest place you can be. But there's all the boarding and all the, intermixing with people. There's too many places where it could potentially happen. And again, I come back to right now where the spread is high. It was the numbers were heading down, and I was getting a little braver myself, but now the numbers are heading up. And positivity rates in some places, again, depends on where you're flying to, I should add. Positivity rates are 30 to 40% in some places. So, you know, it's a really risky time right now. So yeah, I wouldn't.
Professor Hedrick, would you fly?
I haven't, and I would just reiterate exactly what Professor Prather just said. The plane itself, as long as everyone's sitting still and wearing their masks, is probably pretty safe. But getting there and then all the other things that go along with it, getting in the aisle, going in the restroom, being served, all that sort of thing, you know, you just have no control over it.
All right, thank you. Okay, so I will turn to a few other questions that we have in the chat. There's one about, in addition to improving STEM in public education, I've long believed that public education should be part of scientific and technical training. That is, training how to speak about your work and research such that the general public can clearly understand. How and at what level of training might we best accomplish this? And I will turn this first to our two research communications speakers.
Sure. So in the research communications program, that's one of the things that we do. I completely agree that we need better education at all levels of how to talk about research, and not just the facts of the research. I feel like a lot of training really emphasizes just talking about the facts and just taking out jargon and hidden jargon, all of which is really important. But I think another important thing is really talking about the process of science. I think this is the first time that I can think of, at least in my lifetime, that people are really paying attention to science as it unfolds. And it's kind of amazing, right? All of this uncertainty and things are changing. And I think if people had a better understanding of how the process works, it would be easier to understand some of that uncertainty. So I think we need to also help scientists figure out what are the best ways of talking about the process of scientific research and telling some of that story. I was in a AAAS, American Association for the Advancement of Science Policy and Technology Forum last week or the week before. And it was really interesting. It was a discussion about vaccine development. And it was a very educated crowd because it's AAAS members. Yet at the same time, when they asked a poll question, how many people, if a vaccine was available right now for COVID, would you take it? And would you participate in a vaccine trial? So 50% of this very educated audience said, I would participate in a vaccine trial, and only 60% said that they would take the vaccine. After this discussion, which included a very compelling story from someone who worked at Moderna, telling the story of how they were working on that vaccine, and just made it so compelling and really you could feel her passion about it. At the end of this, just an hour, right? They repolled, and this isn't a scientific study, but it was interesting to see that the number of people who would participate in a trial went up by 10% to 60%, and the number of people who would take the vaccine went up to 72%. After just that 1 hour. So I think being able to hear from somebody who's in the trenches, not just about the facts, but about that whole process when they started in January, as soon as they got the sequence until now, and how it was just such a compelling story. It really moved people.
That's great.
I wanted to add that we, Sherry and Mario and I, with Bill McGinnis, have a grant from the Moore Foundation to run workshops. And I can talk about the workshops that I do, but I think Sherry could also add some of the workshops and talks that she's been doing about practicing communicating science. So the workshops that we do, there's one that's called Talking Research. It used to be a 3-day, most of the day workshop that is now being transformed into a 3-day, 3-hour a day, maybe 2-day, 3-hour a day Zoom workshop to practice the science and the art of communicating science and research. They've been extremely successful. I just yesterday was working with a faculty member who had taken one of the workshops, but had done a talk and was uncomfortable with the talk. And so we were breaking it down and seeing how it could get better. So we not only do the workshops, We also sometimes do private coaching with faculty members, particularly if they're doing an important talk or they are working on something that they're going to have to do interviews. Mario runs a workshop that's called the Media Messaging Workshop, in which we practice interviews and interviewing like on the radio or on TV. We practice that. We coach, but we also give some very important principles of communicating. We're also trying to break down some of our workshops into like a workshop about stage fright, because many people talk about they get frozen. And so how do you work with that? One about communicating research inside the box, because there's a whole different space and time aspect to that. And I've just been learning about it over time. Also breaking some of the practices that we do in the bigger workshops into smaller workshops, like working just on metaphors and analogies, or working on stories in the research, working on first and last lines. You know, there are different things that we're going to maybe make smaller workshops about. So we're working on that. Sherry, you want to add anything?
Just the idea that learning how to communicate science, like anything, is really an iterative process. Sometimes we think, oh yeah, we can just send people to a workshop and they're going to come back and they're going to know how to do it. But like any professional endeavor, it's something that over time you develop. And it's also, we talk about this also with students in classrooms, this idea of just-in-time learning, right? Because you learn something and then you don't use it, it sort of fades, right? But if you learn it right before you need it, it really helps that to become ingrained. And so thinking about as a scientist progresses over their career, they might not be talking to policymakers at the beginning. And so a workshop on talking to policymakers might be interesting, but not that useful. But later on, when they're going to be interacting with policymakers, that's a very different audience, and there are very specific ways of interacting with policymakers. And so that workshop becomes useful. And so getting that information just in time can help it to actually stay. So really thinking about it as a process of professional development, like any professional endeavor.
And it takes practice.
Absolutely. Well, thank you very much. That was great. There was a question in the Q&A about whether children are still less affected by the virus, or if we still need to be worried about protecting them.
I can quickly, there's a study that just came out that said they might be, even though they're, quote, less affected, they could be the, quote, super spreaders, that they actually are really good. And nobody thought this just came out like 2 days ago. So who knows, it could change in 2 more days. But right now, you know, kids may not get as sick. They certainly don't show the symptoms for the most part, but they're the ones that can carry it and transmit it back to home. And so that's the concern about kids. And we don't really know the long-term effects of this virus, of this disease on people's health yet. So I wouldn't rule out that they're going to be okay forever either. So I think we still have to be really cautious.
Yeah, I would only add that there were actually there were articles published to say that kids did not transmit the virus. Those are probably completely wrong. And the point is, and so perhaps children are less susceptible to the actual pathology or the effects of the disease, but we don't know, as Professor Prather said. But if they're the source of spread, then that's a problem for everybody around them.
Okay, so I think after that last question is a good time there to answer some questions about how should the public interpret scientific results if one day you hear one thing and then you hear another thing the next day as new results come in. How should the public judge these results that they see in the public literature?
I feel that I'm just going to speak briefly about this, that the more that when you're communicating, you can imagine that your listeners are joining you on kind of a tour of your work and what it is that you do and why you do it and what the process is that Sherry was saying. And so that they can become partners in a way to your research. They can be interested in it. They can be asking questions. They can go, what's happening now? Instead of, so training the audience to embrace the process of discovery, even when you're terrified, that we are actually all really focused on trying to find the solution to this problem. Come along with us and be with us as we figure it out. And along the way, this is what we can give you. This is the information we can give you, and it may change. So if people know that, I think Kimberly just said that, it could change in 2 days. But for right now, this is the information we have. So I would say, you know, there was a question about how do we trust, how do we know that you can be trusted? And I think partly it's telling the truth about the process and telling the truth about where we are in the process.
I have an interest in this, and it's the basis of knowledge. How do we know what we know? When do we know it? What are the source? How do you determine your sources? Things like that. And of course, that's the academic field, subfield of philosophy called epistemology. And it's not trivial. And in an age where people just shout fake news all the time, and there are so many sources of information, some of which on the internet, some of which are you know, less than accurate, it's very, very difficult for people to sort this out. And all I can say is that understanding and science as a process, it's not a single study, or it's not a single paper by one person. It's a process of people who have studied things for a long period of time, and you sort of build up a knowledge base, and eventually things become settled science. But in an era like this, with regard to the COVID-19, you just have to consider your sources and see whether you can understand where their information is coming from, what information they're trying to convey. Do they have a bias? And are there more sources that can confirm that any particular piece of information that you come upon?
I think that's all really excellent advice. I just want to add one thing for people trying to make the sense of things in the media and that sort of thing. A lot of times reporters aren't the ones who write the headlines. Sometimes editors are the ones who write the headlines, and sometimes much to the chagrin of a reporter who has written a fairly balanced story, but then the headline that you see is not balanced at all. And if you read a lot of articles and, you know, kind of get past those first few paragraphs, you realize that the statement in the headline that was definitive about coffee killing you or whatever it was actually ends up being almost retracted by the end. And so sometimes the media is responsible for blowing those disagreements out of proportion. And so if you're trying to make sense of that information and something important to you, right? If it's not that important, you might just look at a headline and go, whatever. But if it is something really important, kind of skim through and make sure that at the end, they haven't kind of gone back, well, this is just one study and it's very tentative and it probably doesn't overturn what we knew before, that sort of thing.
Thank you very much. Those were all wonderful answers. There's a really interesting question in the chat that starts with, why should we trust you? I am a scientist and acknowledge your scientific expertise, but for non-scientists, this is not as persuasive a factor. So how do we as scientists instill trust in science to non-scientists? What are the best practices here, given that the media might take what you told them and have this racier headline so that they can get lots of reads on their articles?
I think that one of the things to be aware of is that we are, I think, collectively in a very heightened state. Our amygdalas are like firing all over the place. We are in a heightened state of flight, fight, whatever that is. You know, and I think that oftentimes media will be like, well, what can we hit? What's the fix? You know, it's almost like an addiction. You know, what is it that we can say that'll cause a big interruption or a big stir? And I think that the more scientists can communicate in a steady, clear fashion, but in a fashion that really feels like we're all in this together. I mean, I think one of the positive things about this COVID era is that there is a collective focus on finding a solution globally. I mean, that is something that's actually quite remarkable. So if we can bring the listeners in on, we are all in this together. We're on the journey together. You know, we're like in, what is that movie about Invaders of the Lost Ark? Was that what it was called? You know, like it's a mission, and we're all doing it together. And there will be obstacles, and there will be crisis, and there will be things that contradict. And we are all together figuring it out. And we have experts to guide us.
Thank you. Would either of our other panelists like to add to this?
I would just like to add something about scientists getting things out in their own words. And there's some really practical ways. I mean, obviously you want to spend time in the lab doing actual research. So there's a finite amount of time for this, but some very practical things is if you can, if you are savvy and you can, make some kind of a video or have a blog. If not, at the very minimum for each one of your scientific papers, you have a scientific abstract that often is impenetrable. Translate that scientific abstract into a lay language abstract. And you might even get help from somebody from your discipline and display that side by side so that people can have that and people can go back to it. I think one thing we've seen during the pandemic is that people have wanted to hear from the scientists directly, right? I think there's been a real call for that. And so having that opportunity can be, can get past some of those headlines. Oh, I saw that headline, but then I heard that scientist speak, or I went back and I actually looked up that thing that they wrote and it wasn't exactly that.
There was a question from the audience about what is the best source of information on COVID and SARS-CoV-2 for the public? Professor Hedrick, what public sites do you use when you want to dive in and get more information on how things are going?
Oh, gee. I tend to read the primary literature, so that's not a very good answer. Although, I must say, I certainly look at all the headlines that pop up on the internet and see whether there's anything juicy. But then, honestly, it's so complex, I go to the primary literature. I wouldn't say that it's an easy question to answer. What is the source? I don't think there is one, really.
Yeah, I think that's absolutely a fair source. The county departments of public health will at least provide data that you can look at to see how things are going in your region. So that can be useful as well.
If you can find the number of hospitalizations and actually the fatality rate, those are independent pieces of information that don't depend upon the rate of testing or the accuracy of the tests. When you look at tests, it does depend upon how actively any community is testing. And so just because a county reports very few diseases doesn't mean there aren't diseases around. It's just they may not have been testing very avidly. I don't know. I'm sorry. I can't really answer that question very well.
No, that was great. Scientists do have a tendency, we first will read something in the newspaper if that's where we see it first, and then we'll immediately dive in and try to see if the results, if the work in the paper's been peer reviewed, where it was published, how many people were part of the study. And that's totally a natural response. And it's what we all do as scientists. It's a harder thing for the public. So then I recommend relying on your local public health authorities. And Johns Hopkins University also has a really highly regarded tracker of the COVID-19 outbreak. So that's also a really nice source. And the University of Washington's been doing really great things with their public health initiative. And if you happen to be interested in how things are going on the UC San Diego campus, our public COVID dashboard has a lot of information. You can see the state of the infection on campus with students living on campus or off campus, as well as with our staff, both on the main campus and in the health system. So it's a great public dashboard.
Also, both Nature and Science have publicly available summaries of the COVID epidemic that you can look at weekly.
Perfect. Thank you. Okay, so we're about ready to wrap up, and I just wanted to invite the panelists, if there's one last thought that they'd like to leave the audience with, I'd like to invite them to just say a couple of things if they want to give the audience some advice or have any final comments here.
I would just like to offer something optimistic, and that is that crises like pandemics are focusing events. They're times when scientists and policymakers and the public are all focused on one problem. And so the optimistic part of that is if we are all focusing on this one thing and really seeing how important it is, there's the possibility of us emerging, as we said, together from this and bringing every kind of expertise to bear in it, right? Because there's a lot of different expertise. We talked today mostly about scientific expertise, but there's also the sociologists who are studying behaviors and all of these other things. And so bringing all of that together, and I think the fact that the public is watching this all happen in real time and is really interested in it because it's, affects our lives so deeply, that it could be a really good time for science going on into the future, realizing how important it is and how important basic research is, right? Because Kim Prather's research was sort of basic research, right? And also Steve Hedrick's research, also basic research. But these are then going to be applied to these really important problems. So hopefully a better world emerges, right?
Thank you.
There's a couple questions about what if you're talking to people who don't trust science, don't believe in science, or have a contrary view to what it is that you are presenting. And I want to repeat that if you can find common ground between you, because we all want to be safe, we all want to be protected from this COVID virus. We all want to know that there is a path towards a solution. So those are some ideas of common ground. If you can stay within that, within that as the womb of your conversation, it's not about trying to change the other person. It's not about trying to make them think differently or feel differently. It's about saying, I'm scared, you're scared. We have this collective thing that we're working on together. We may have different ideas of what that means, but we are doing this together. That is, and all I can do is say from what I know and what I'm working on and give you that information with authenticity, with clarity, and with honesty. And hopefully if you set up that kind of relationship, then you are actually in relationship. And that is, I think, very important right now. And my last thought is that this kind of conversation, to be able to have this kind of weekly, bi-weekly place where people can go, ask their questions, and be in relationship to the scientists.
Great. Thank you. Well, I have really enjoyed all the presentations from the group. And I really have found it a fabulous conversation. And I hope that the audience has enjoyed it as much as I have. And I'd like to just thank our panelists and for their valuable perspectives about the pandemic, in this perilous moment in history during which trust in science is truly being tested. And the uncertainty that surrounds us is weighing heavily on all of our lives. I'd like to thank everyone for taking the time to join us this afternoon during this fabulous talk, and invite you to join us again on November 19th for our next installment in the Deep Look series, when we will discuss the disparate impacts of COVID-19 on different members of our community, which is widening socioeconomic disparities. This will feature Suresh Subramani and experts from UC San Diego Health and the School of Medicine. So thank you all. Stay safe. Remember to wear masks and be outdoors when you interact with people to the greatest extent possible and in the largest space. So thank you so much and enjoy the rest of your day.